Hi guys. These are the solutions to your Chapter 3 test. I will break the video up into the front page and the back page, so as always, correct all the problems that you missed. You can skip ahead to what you need to see, or you can watch the whole video. So starting on the front page, questions 1 and 2 have the same directions. It says, write an inequality for the graph. Alrighty. Well, as you remember, when we're talking about our inequalities, we usually like to see our variables on the left. So for both of these, I'm just going to start by picking a variable. It didn't matter if you chose x. I just like x. It's one of my favorite variables, but you could have chosen any other variable. So we're just going to start here. X is going to be on the left. Let's figure out what kind of inequality symbols we're going to have. So in question 1, I have an open circle. So if I have an open circle, that leaves me two options. That's either less than or it's greater than. Well, let's look at what's happening with the arrow. Is the arrow pointing to numbers greater than -1, or is it pointing to numbers less than -1? Let's see. Going to the right, looking at the numbers, I have 0, 1, 2, so on and so forth. These numbers are all greater than -1. So I have x greater than -1. And that is your answer. There's nothing more to this problem. Question 2, it's the same idea. I already started with my variable on the left. Let's figure out the inequality symbol. So I have a closed circle, so that narrows it down to less than or equal to or greater than or equal to. We have to look at the arrow to decide which one. If the arrow is pointing to numbers less than -2, then we know it's less than or equal to. If the arrow is pointing to numbers greater than -2, then, well, it's greater than or equal to. So let's see, our arrow is pointing to numbers like -3, -4, so on and so forth. Those numbers are all smaller than -2. So this means my inequality symbol is less than or equal to the number -2. And that's it. Questions 3 through 7 says, write the word sentence for an inequality. You're not solving anything. You guys should have known or written down your keywords for the inequality symbols, and if you didn't, then these questions might have challenged you. Well, let's just start with number 3. A number n, okay, so that's my variables I like on the left, so I'm going to start there. A number n is no less than, that's an inequality symbol. It's no less than what? It's no less than -3. So I know -3 is going to be here on the right, no less than. If you didn't know your keywords, or you didn't write down the keywords for each inequality symbol, then this is probably challenging. But on this, no less than is actually the inequality symbol, greater than or equal to. So the smallest this could be is -3. It's really going to mean it's anything bigger. N has to be bigger than -3. So that's your inequality statement. Question 4 says a number q, again that's my variable, q is my variable, it's going to go here on the left. I'm going to make my q's a little curly because my q's tend to morph into 9s. So here's my curly q. A number q plus, ooh, something different there. Plus is a math operation, it's addition, so I'm going to draw a plus sign. Plus what? Plus 7 is less than, well, less than is an inequality symbol. Less than what? It's less than 45. So I'm going to read left to right. A number q, got my q, plus what? Plus 7 is less than what? It's less than 45. This right here is your inequality statement. Again, if at any point you're not sure what's going on, please come see me in 7th period for more help. Question 5. It says a number x, that's my variable. Variable's going to go written on the left. X divided by, that's a math operation. So I'm just going to draw the little division symbol. I'm going to run out of space. Division symbol. A number x divided by what? It's divided by -1. And this is at least, at least is another inequality symbol. If you didn't know or you didn't write down those symbols, then this is probably challenging. At least is greater than or equal to. And what is it greater than or equal to, or was it at least? It is at least the number -4. So let's go back left to right. A number x divided by what? Divided by -1 is at least, or the symbol greater than or equal to, at least -4. Now there are two ways you could write it. You can write it the way I did it with the division symbol, or you could have written it like a fraction. If it's written as a fraction, remember fractions are still division problems, you have x over -1 greater than or equal to -4. Both are correct answers. Okay, number 6. The children in the class are more than, well, I know more than, that's just the greater than. It's more than what? More than 10. Now I'm missing something. It didn't tell me a variable right away, but I don't know how many children are in my class. So this phrase, children in the class, I don't know what that is. I'm going to represent what I don't know in math with a variable. And again, x is my favorite, so I'm just going to choose x. So when I translate this into math symbols, I have my unknown, or the children in the class, x, are more than, or the symbol greater than, 10, or 10 years old. That is your inequality statement. Some people mixed up more than with more than, or the greater than or equal to symbol. If it was a greater than or equal to, those words would be in the statement, or an equivalent phrase for greater than or equal to, like at least, no less than. Those are just a few examples. Question 7, last one of this section. It says the minimum cost, minimum is definitely an inequality statement, and if you had your cheat sheet, or not your cheat sheet, I'm saying you wrote down the words from your cheat sheet, the minimum represents greater than or equal to. So the minimum, or the greater than or equal to cost for parking is $3. Well, again, it's the same kind of idea as 6. We don't know what our variable is. It didn't give us that information, so we have to come up with one ourselves. Well, in this sentence, I don't know what the cost of parking is. So right here, this cost of parking, this phrase, I don't know what that is. So this is actually representing our variable. And again, x is my favorite, so I'm just going to do x. When I translate this, I realize our variable's on the left. So I'm going to start with x. And this looks different because it's not going left to right in order as every other problem. You just need to remember that where we like our variables is on the left versus the right. So here we have x and the minimum of it, so we're going to jump to our inequality symbol, greater than or equal to. It's greater than or equal to what? It's greater than or equal to 3. So that is your inequality statement. This one was commonly missed because of the word minimum. And if that wasn't something you put on your note card, then this is probably challenging for you. Okay, let's move on. Questions 8 and 9. Same directions. It says, tell whether the given value is a solution of the inequality. So what that means is they're going to give us a value like they did in 8 and 9. 8, they gave us j is 9. In question 9, they gave us k is -1. What we're trying to do is plug in this number, the number they gave us for the variable, and see if we get a true statement. So in question 8, I have the inequality j plus 1 greater than 10. I'm going to, instead of writing j, I'm going to replace it or substitute it in for the number 9. So I have 9 plus 1 greater than 10. I'm going to put a little question mark over my inequality statement. I'm like, I'm not sure this is true yet. Let's see. 9 plus 1, well, that's 10. 10 greater than 10. Well, that's not true. 10 is not just strictly greater than itself. This would be a true statement if this were greater than or equal to. But since 10 is not strictly more than itself, this is not a solution, or no. This is not true. However you want to do it, false, not a solution, no solution. There are a lot of ways you could say no. This is not true. Question 9. It's the same idea, but this time we're going to replace our variable k with the number -1. So I'm going to draw a little arrow just like I did before. Instead of writing k, we'll plug in -1. So this gives me the inequality statement, -3 less than or equal to, getting a little question mark, I'm not sure yet, less than or equal to, instead of writing k, we'll have -1 over 2. Well, let's see. -3 less than or equal to -1. -1, if it's actually greater than -3, it would mean it's closer to 0. Well, that's definitely a true statement. If I think about my number line, here's 0, here's -1, -2, -3, here's -3, -1/2 is right here. This is -1/2, that's -3. -1/2 is definitely closer to 0, which means it is definitely greater than or equal to my -3, or vice versa. -3 is smaller than or equal to -1/2, which means it's farther away from 0 than -1/2. That is true. Or yes. However you wanted to say that would be fine. Okay, let's keep going. This is the last problem on the front page. Remember, I skipped number 10. I had you guys cross that out on your tests. Oh man, this is a tough problem. So 11. It says, an elevator can carry 800 pounds of weight. Okay, that's good information. A student weighing 95 pounds gets on the elevator. Write and solve an inequality to represent the remaining weight that can be added. Okay, well, the remaining weight. I don't know what that is. Remaining weight is going to represent my variable. You have to have a variable in this. This is not a statement where you're saying one number is strictly less than or is less than or equal to whatever inequality symbol you think is than some other number. It has to have a variable. There's still more weight we could be adding. We just don't know what it's going to be yet. So the remaining weight, I'm going to represent it with x. On elevators, if it's giving you this weight limit, this is actually the max. The maximum amount of weight I can put onto my elevator is 800 pounds. So there's a secret max in here. We didn't actually write the word, but max represents represents less than or equal to. Okay, so let's start writing our inequality for this first problem. I already identified what my inequality symbol is going to be. Remaining weight is my x, and I'm adding whatever my remaining weight and the one person that got on. So the first part is writing the inequality. So I'm going to start with remaining weight, so whoever else could get on, plus the one student who weighs 95 pounds. This all combined has to be less than or equal to the max weight, which is 800 pounds. So right here, this is your first part of the problem. This is my inequality. The second part on A asks you to solve it. So I'm just going to get x by itself. Oops. To do that, I'm going to undo the addition of 95 with some subtraction. So I'm going to subtract 95. So this gives me the solved inequality of x less than or equal to 705. So I'm going to kind of put a big box around this. This is A. Now, B can use the answer from A, or you can just start all over. It doesn't matter. I will show you both. You'll get the same answer regardless. So let's just start by reading the problem. B says a football player weighing 280 pounds gets on the elevator with the student. Some of you forgot this part, with the student. So this is going back to A, with the student who's weighing 95 pounds. So when it says with the student, I'm actually going to put that weight. That's 95. And then same directions. Write and solve an inequality representing the remaining weight that can be added. Just like in A, the remaining weight is unknown to us. We don't know how much is left yet. I don't know how many other people are going to get on. I don't know what the total weight will be. So that's going to be my variable, or my x. So let me go way over here. There are two ways to write this. So option 1. Option 1 is using your answer from A. So use answer from A. I look like a 9. A to answer the rest of this. If you do that, that just means that the max weight is no longer 800, it's 705. So I could say, using my option 1, I have my unknown remaining weight of X plus 280 less than or equal to 705. Now, by using the answer of A, I don't have to account for my 95 again. That is already accounted for with the 705. So option 1 is just using the answer that you started with in A and adding on that weight from the football player. You'd still have to solve it, and to solve it, you'd subtract 280. And this would give you a solved inequality, X less than or equal to 425. Now, option 2 is probably a good safe option. Chances are you'll make a mistake using option 1. So option 2 is just starting from the beginning and accounting for the student that got on in part A and the football player and the original max weight. So this would be, I would say, start from beginning. What that means is I have my unknown remaining weight, whoever else could get on, plus my original 1 student who weighs 95 pounds, plus the football player who's 280 pounds. And when this comes all out, added all together, it has to be less than or equal to 800. This is the original maximum weight for our elevator. Then from here, you're just combining it. So we have the pink X 95 plus 280 is 375. A lot of people made some just tiny little mistakes here by adding incorrectly or subtracting incorrectly. Just be very careful. Check your work. Go slow. It's okay. So either of these answers, I'm going to do a little purple dot here, either of these would be acceptable answers for the inequality statement, but we still have to solve it, and to solve it you'll get the same answer as in option 1. We're subtracting 375 from both sides. When I do that, that gives me X less than or equal to 425. So it doesn't matter which option you choose. If I was learning this, if I was in your spot and only seeing this for the first time, I would probably want to lean towards option 2 over option 1, just because if I start from the beginning, then I know I am accounting for all pieces of information. But you can choose. That is up to you. Question 3. It says 2 more football players weighing a total of 470 pounds come to the elevator. Can they get on safely? Well, again, there's multiple ways you could have started this. There's the option 1 of using the inequality statement from B and then adding in your 470, or they're starting from the way beginning. I'll show you the way beginning to start. So I'll really kind of do my option 2. The reason I'm choosing to do option 2 is, again, if I were in your spot and I was seeing this for the first time, I hadn't done this much as I have in my time here, going back to the beginning and accounting for every piece of information, make sure I don't miss anything. So let's just start with, I still don't know if there is any remaining weight, or X. I have to account for everyone who's on my elevator right now. So I have plus my student, who's 95 pounds, plus the 1 football player from B, who is 270, plus the 2 more football players that weigh a total of 470. Whatever this adds up to be, it has to be less than or equal to the max weight of 800. Well, if we go through all of this adding, we'd have 95 plus 280 plus 470. That comes out to be 845 less than or equal to 800. I don't even have to solve it. I just can look at this right now and say, well, I'm definitely already over my max limit. With the total of 3 football players and 1 student, I can't have anyone. I can't even hold all of them because I'm already at a total of 845 pounds, and my elevator can only support 800. So this is no, they can't get on safely. No. No, they can't get on safely. They'll exceed the weight limit. And there you go. That is the first half of your test.